guys, welcome back to my channel. Today we're going to be working on fractions. We're going to start with the basics and then move on to the more challenging questions later on. Okay, so first of all we start with common fractions, and we're going to start off with equivalent fractions. Now remember, all my packs are on my website www.mrsdupreez.co.za. There is a link in the description box down below, so feel free to go onto the website and purchase a pack. It will help you. I've given a lot of instructions and a lot of guidelines of how to do certain parts of the fractions, and it will help you a lot. Okay, so let's get started. Okay, so first of all, an equivalent fraction is a fraction, or equivalent fractions are fractions that are equal to each other. Okay, and they have the same value. So it doesn't matter what happens, all I need to know is that my two fractions have to be equal to one another. Okay, so if you look at this one, what I've done is I've given you an example of a third. Now what you'll see is I've drawn arrows here, and all I've done is I've times the top number by 2 and the bottom number by 2. Okay, and by doing that I've actually made it equal to one another. Now remember, equivalent fractions also helps us when we get to the point of trying to simplify our answers. So remember, I could have gone backwards and divided by 2 and got 3, divided by 2 and I got 1, and so those two are equal to one another. Okay, so whatever you do to the top, you have to do to the bottom. Okay, so now in this example, I just wanted you to see how to convert 1/3 into 3 different equivalent fractions. And all I did was I times top and bottom by 2 each time. So here I did 1 times 2 and I got 2. We did 3 times 6, or 3 times 2, sorry, and you get 6. Here we did 2 times 2 is 4, and 6 times 2 is 12. Okay, and then I took the 4 times 2 and I got 8, and I got 12 times 2 is 24. So all I did there was whatever I did to the top, I did to the bottom. So in this case, every single time I just times by 2. And you'll notice that each of these are the same. Okay. Now I just want to quickly show you, just so you can see this visually, that we've got a third here. So these are little fraction blocks that I've got at home, and I use them to help teach, or to teach fractions. So what I want to show you is that in our diagram here, I showed you that if you times the numerator by 2 and the denominator by 2, we're going to get 2 over 6, and that means these two are equal. And I want to show you how true that is. So we've got a third. As you can see, this is a third. I'll just show you as if it was a whole, that it does make up a third. Okay, so there's your third. And I've got blocks that are a 6. You'll see at the bottom it says 1 over 6. I think you can see it on the camera. But I just want to let's just take these two away, and we're going to keep our 1/3. Okay, and I just want to show you that if I put both of these on top of each other, that it does equal. Okay, so there we go. Can you see that there's no spaces? There's no overlapping, nothing's gone wrong there. We can see that 1/3 is equal to 2 over 6. Remember, this is 1/6 and that's 1/6, and if we add them together, we're going to get 2 over 6, which is exactly what we have here. Okay, unfortunately I don't have any 12th ones, but you could probably imagine it's going to be the same. Remember, 1/12 is going to be half of 1 over 6, so you can imagine 2 would fit here and 2 would fit there, and you would have your 4 over 12. Okay, just wanted to show you visually what that looks like. I just want to do another one because we're going to get there just now. Is if I have a half and you want to see how much what fraction would fit onto it, I want to try a quarter. So remember we said if we take 1 over 2 and we have got quarters and we times top and bottom by 2, 1 times 2 is 2 and 2 times 2 is 4, which means we need 2 lots of quarters, and here I've got the quarters here. Can you see that works perfectly? Okay, now at the same time, just go back to 1 over 2. I'm going to times top and bottom by 3. So instead of timesing by 2 now, I'm going to take 1 over 2 and times it by 3. So 1 times 3 is 3, and 2 times 3 is 6. So if I get my 6 blocks out, notice that I just said 3 over 6, okay? And I want you to just have a look here. Can you see that they still do fit? So it doesn't matter what number you times by, whether it's 2 or 4 or 6 or 10, it doesn't matter. You will still get the same answer as long as you times top and bottom by the same number. And I just want to show you one more, just so you can trust me on this. If I times half 1 over 2 by 4, 1 times 4 is 4, and 2 times 4 is 8. And I just want to show you, I can see I'm going a bit off the sides here, so we just need to position this nicely. And we've got that. And if we put it perfectly like that, you'll notice that 4/8 will fit onto a half. So that means a half is equal to 2 quarters, 2 over 4. It is also equal to 3 over 6, and it's also equal to 4 over 8. Now the reason why we need to know equivalent fractions is because we always have to work with the simplest form. Now the simplest form is, obviously if I've got 4 over 8, I need to divide top and bottom by 4, and I'll get 4 divided by 4 is 1, and 8 divided by 4 is 2, and I'll get 1 over 2. And I always give this example, and the kids always laugh at me, but imagine if your teacher or someone comes to you and asks you for half of your donut. Okay, but instead of saying they want half of your donut, they want 4/8 of your donut. Just sounds a bit weird. Rather just say you want half the donut. Okay, so it is much easier. You'll see that simplifying at the end of the day is the best way to go, and obviously you'd get the marks for it. Unfortunately, if you don't simplify, sometimes the teachers don't give you the marks because you need to get down to the smallest fraction that you can. Okay, alright, let's move on. Take this away. Okay, so here's some extra examples that I've given you, and I've just wanted to show you that you don't, and like we did now, I just want to show you that you don't always have to times by 2 only. Okay, in this case I times by 2, top and bottom, and I got 6 over 8. I've done the working out here. The next one I took 3 quarters, and I times top and bottom by 3, and I got 9 over 12, and there it is there. And then this one, 3 times 10 and 4 times 10, I just times 10 top and bottom, and I got 30 over 40. So if a teacher in a test ever asks you, write down 2 equivalent fractions for the following, all you're going to do is times top and bottom by the same number. And obviously you do that twice, so that you've got 2 different fractions. So 2 fractions that are the same value, but you've got 2 separate ones. Okay. Some kids are very clever. They find this one the easiest one, because anything times 10, we just add a 0 on it. So I've always thought that was quite clever. But try not to go too big. You know, sometimes we try and make it very fancy and trying to show off a little bit, and we try and times by 11 or 15 or something. And then sometimes we make an error. So just keep it simple. Times by 2, times by 3, keep it as easy as possible. Okay, that's the point of maths. We want to try and make it easy for you to understand. Alright, so what you would do is, for now, we are going to just do the top A, B, and C. We won't do the others. You can do this. If you've got the pack, you can obviously do these at home. But we're going to write down 2 equivalent fractions for each of them. So we've got 2 over 5. If I times top and bottom by 2, I'm going to get 2 times 2 is 4. 5 times 2 is 10. Okay. But it says 2 equivalent fractions. So just because I wrote that doesn't count as 2. So now I need to do it again. And we're just going to times by 2 again, times by 2 again, and you're going to get 8 over 20. Okay. Let's go on to B. 3 over 7. So now you don't always have to write times 2 times 2 times 2 times 2. You can do it in your head if you can. So it does make it easier. And I mean, obviously you can use it in do it in pencil as well. But we're going to try to do these without writing times 2 times 2. Okay, so 3 times 2 I know is 6. And 7 times 2 is 14. Nice and easy. Let's times 2 again. 6 times 2 is 12, yes. And 14 times 2 is 28. And there we go. Now you don't always have to use 2. Okay, you can use 3, you can use 4, you can use 5, whatever works for you, you must do it. Okay, let's try with C. We're going to do 9 times, well, let's do 3. Let's times 3 by this time. So 9 times 3 I know is 27, and 11 times 3 is 33. And what we can do for the next one is, instead of timesing by 3 again, okay, because 27 times 3 is going to be a little bit of a challenge, let's just times by 10. So go back to your original one and times by 10. And we're going to have 90 over 11 with a 0, which is 110. Okay, so 11 times 10 is 110. Alright, so that is what you are going to do when you are asked to do 2 equivalent fractions. Okay, this is really going to help you when it comes to adding and subtracting fractions as well. Now you can do the next 3 on your own and see if you can get those right, and you can choose whatever you want to times by. Now we're going to go on to converting to improper fractions. So something that we didn't do earlier, and we didn't speak about it, but we need to know the difference between all 3 fractions. So you have something called a common fraction or a proper fraction. Okay, and a proper fraction is your normal fraction that you are used to at the moment. 3/4, a half, a tenth, 7 over 8, any of those. Okay, then you might get something called an improper fraction. Okay, so an improper fraction is a fraction that is top heavy, okay, which means that the numerator is bigger than the denominator. So for example, you're going to have something like this. You'll have 19 over 3 and 10 over 9, or maybe even 3 over 2, or maybe even 6 over 4. Can you see that the numerator is bigger than the denominator? Okay, and then the last type of fraction that we get is something called a mixed number. Okay, and a mixed number is pretty much just that. It's got a combination of a whole number and a fraction. Okay, so can you see how mixed it is? It's got the whole number and then it's got a fraction next to it. So that could be anything. You could have 2 3/4, you could have 25, and let's make it 4 over 5 just for fun. Any of those. So you need to know the difference between a proper fraction, an improper, and a mixed number, because what we're going to do now is we're going to start making them change from improper to mixed, and then from mixed number back to improper. So I'm going to teach you that right now. Okay. Alright, so let's start with converting to improper fractions. So when you're converting a mixed number into an improper fraction, we need to make the fraction top heavy. Okay, so we need to make it bigger on top than it is at the bottom. So what we're going to do is we are going to take the denominator, times it by the whole number, and add the fraction at the top, or the numerator at the top. Okay, so in this case we've got 6 and 1 over 3. Can you see you've got 6 lots of a third? Okay, because remember this is 6 whole. Okay, which means it's going to be 6 times 3, or 3 times 6, and then there's 1 left over, and you've got the 1 there, so we must add it. And then obviously you must keep the denominator. So whenever you are converting to improper, from a mixed number to improper, you are going to times into the whole, so take the denominator, times it by the whole number, and then add the top number. Okay, add the numerator, and then you will be left with 19 over 3. So in this case, 3 times 6 is 18, add the 1, and you get 19 over 3. Remember, we're looking for an improper, so we need to keep the denominator, and your top number must be bigger than the bottom number. Okay, let's go to the next one. Here we've got 7 3/4. So we're going to do exactly the same. We're going to take 4, times it by 7, okay, because there's 7 lots of 4, so we're going to take 7 times 4, and we're going to get 28, and we're going to add 3 to it, and we get 31 over 4. Now you'll see I didn't write each of the steps here, but if you want to, you're more than welcome to. 4 times 7 is 28. 28 plus 3 is 31 over 4. So remember, we just keep the denominator again. Now I've given you a couple of examples. Here's another one, 10 and 1 over 3. We're going to take 10 times 3, because remember there's 10 lots of 3, and that's going to be 30. 30 plus 1 is 31 over 3. Now I've written here that you don't always need to write this part out. It's just I wanted to show you how to work it out, but a lot of children still do it. So you are more than welcome to write it out. If it is going to help you and you're going to get the marks for it, or you're going to get the correct answer, then you must do it. Okay. Alright, I've given you a couple of other examples of how they do it in certain situations. So every teacher is a little bit different and kids understand it a little bit differently. But I've done the same here. So all I've done is 4 times 2 and then added the 3. So I just put it into a bracket, so we times that first and we add the 3, keep the denominator, and you got 11 over 4. Here we've got 2 and a third. All we did was we took 2 times 3 and kept it over 3, which is still 6. And then we've got the third still, so 6 plus 1 is 7 over 3. Okay. Alright, so let's try this. We're going to only do the top 3 again. And let's see how to do this. So I want you to try it and then check if you are correct. Okay, so what we're going to do first with 8 3/4 is we're going to take the 4 and times it by 8, because remember there's 8 lots of quarters. So we've got 4 times 8 is 32. 32 plus 3 is 35, and for 35 over 4. Okay, next one, 12 and 3 over 5. 5 times 12 is 60. 60 plus 3 is 63. And then your last one over here, and I've got 6 1/4. It's very similar to this one, but it's obviously got a quarter at the bottom, or 4 at the bottom. So now we're going to have 4 times 6 is 24. Add the 1 and you're going to get 25 over 4. Now when you are doing these on your own and you're practicing them on your own, try, if you can't do them, go back and see what we did. Read what's been told, what's been said here. Okay, because if you don't understand it, rather go back and try it again and try it again until you get it right. Okay, maths is all about practice. Okay, and especially fractions, we need to practice fractions. Okay, now we're going to move on to converting to a mixed number. Okay, so when converting to a mixed number, we need to make sure that we're left with a whole number and a fraction. Okay, so now we're doing the opposite of what we did earlier. Now we've got the big number on top and the smaller one at the bottom, and we actually need to make it have a whole number and have a fraction. So I've given you a step-by-step count of how to do this. Okay, and hopefully it will help you when you get to doing these by yourself. So let me just go through it with you. Here we've got 45 over 6. So we've got 45 lots of 6. Okay, so let's see what we've got. So what we do is we say 6. So we go 45 divided by 6. Or we say, how many times can 6 go into 45? Now you know your times tables. You may use your fingers if you need to. 6, 12, 18, 24, 30, 36, 42, 48. Now 48 is too big, so let's just go back. Can you see we've got 7 lots? Okay, so I've got 7 lots. 7 times 6 was 42. How much more do I need to get to 45? So we sat on 42, 43, 44, 45, and that is an extra 3. So you've got 7 lots, or 7 whole, and you've got 3 left over, and obviously we keep our denominator, so we've got 7 3 over 6. Can you see that I've still got 3 over 6 and I haven't simplified? This one can be simplified, and this is something that you need to get used to doing, is as soon as you see a fraction, try and see if you can find a number that can go into top and bottom. So we've got 3 and 6. I know that 3 can go into 3 and 3 can go into 6. So if I divide top and bottom by 3, can you see that I'm left with 1? 3 over 3 is 1, or 3 divided by 3 is 1, and 6 divided by 3 is 2. So my final answer is 7.5. Okay, let's go on to the next one. 29 over 4. We're going to do exactly the same thing. We're going to see how many times can 4 go into 29. And again, you need to know your times tables. 4, 8, 12, 16, 20, 24, 28. Okay, so I can see it goes in 7 times. So that's 28. How much more from 28 do I need to get to 29? Okay, only 1. So there's 1 remaining, so it's 7 and 1 over 4. Okay, and these ones I want you to practice. I want you to try and practice these as often as possible. And I know it's not the most exciting thing in the world, okay, but it is important that we get these right. Okay, so here we go. 32 over 3. So let's see, we're only going to do the first 3, and obviously the rest you can do later. Okay, 32 over 3. So I can see straight away, without even having to use my fingers, 3 can go into 32 10 times, because what 10 times 3 is 30. How much is left over? There's a 2 remaining, and it's 2 over 3. Okay, let's try the next one, 41 over 9. So if you know your 9 times tables, 9 times tables, so it's 9, 18, 27, 36. If I go one more, it's 45, and 45 is bigger than 41, so we can't do that, so it must be the 4. So we've got 4 there. So what did we say? 4 times 9 is 36. How much more do I need to get to 41? And that is 5. Okay, last one is 62 over 8. I know that 8 times 7 is 56. Okay, and then 8 times 8 is 64. So we can't use the 8 because that's too big. So we're going to use the 7. And I know 7 times 8 is 56. How much more do you need to get to 62? So again, if you need to use your fingers, use them. So 56, 57, 58, 59, 60, 61, 62. So that's a 6 over 8. But what do you notice? I hope you've all seen something that you've noticed. Can you see 6 over 8 is not simplified? We need to make that smaller. So we are going to divide top and bottom by 2. Okay, and now we must still write the whole number. Okay, you must still write the whole number, and then you're going to write the simplified version. 6 divided by 2 is 3. 8 divided by 2 is 4. And that is your final answer for converting that one to a mixed number. Now, the reason why I wanted to do this one with you is because there are plenty of children who get to this answer, and yes, that is correct, but we haven't simplified, so then unfortunately you might only get half the marks. But then what they do is they'll do equals, and they just divide this part, and then they write equals and then 3/4. But they forgot to put the 7 in front. So yes, the fraction is correct, but they forgot the 7. So then that's still wrong. So if you can see where I'm coming from with this, try to always remember whatever's in front of the fraction must still come there. Okay, it must still belongs there. Alrighty, let's go to something else. Okay, one of my favorite topics to teach is comparing fractions. Now we use something called the butterfly method. So it sounds a bit weird, but it's called the butterfly method. And what we do is when you are comparing 2 fractions, so for example in this case we were comparing 3/4 and 7 over 8. Now if I just look at them, okay, I can't really tell which one's bigger. I mean, I might be able to, but you know, if you don't know your fractions, then you might get a bit confused. Okay, so there is a method that really is so easy, and it's so simple to use. Okay, so we call it the butterfly method. So what you do is you are going to circle it to make it look like a butterfly, but you're going to circle in a diagonal direction. So you are going to position it like this. So you're going to take the one denominator and go around like that, okay, and go around the numerator of the top one, and then you're going to do the same. Now you'll notice I go up and then I come down. Do you notice that a butterfly generally goes up? When it flies, it has to go up. So I always use that to help you to identify where you're going to write your numbers. So what we do here is, now that we've circled them, can you see how I've grouped them? So you're going to times 4 and 7. So 4 times 7 is 28. Okay. And 8 times 3 is 24. And can you see that this side is bigger? Because the 28 is bigger than the 24. Now this is what this butterfly method does. It helps us to identify which side is bigger. And then you can put your bigger than, smaller than, or equal to in. I always like to call it the crocodile mouth. Even in grade 7, I still called it the crocodile mouth. Okay, so this is a really, really nice way of working out which side is bigger than the other. Okay, so all you do, just as a reminder, we're going to take the bottom denominator and circle it around and group it with the top numerator of the other fraction. We're going to do the same with the bottom of the denominator of the second fraction and group it with the top numerator of the first fraction. And then what you do is you're going to, remember, a butterfly is going to go up, it's going to fly upwards, so you're going to go up. 4 times 7 is 28, 8 times 3 is 24, and then you're going to decide which way your crocodile mouth goes. Okay, so please remember that you must do it in this direction. Okay, I've had it where I've had children put them in the opposite direction, and then obviously their answers are all wrong. So please, please remember, your butterfly is going to go up, and it's going to go up, and so that's where you write your answers. Okay, so this works for all of your fractions when you are comparing them. If you look at this one's quite cute. I got this one off the internet. 6 times 3 is 18. You'll see they actually put little feelers in. I think it's quite cute. So you got 6 times 3 is 18. You'll see 10 times 4 is 40. And obviously it's going to go in that direction. Okay. Now sometimes it's very simple. Sometimes you can see automatically whether one is bigger than the other. Okay. But if you can't and you want to be sure of it, use this method because it's very, very quick and it's very easy. Even if you don't draw your butterfly in, if you just go 4 times 23 is this, 7 times 13 is 91, and then you've got your answers and you can find it quite quickly. Okay, now I've given you some more challenging examples, and they're actually not that challenging, to be honest. We're going to use mixed numbers. Now this is actually quite simple, to be honest. If I give you something like 3/4 or 3 1/4 and 3 2/7, can you see that the 3's are the same? So generally we're actually just going to look at the fractions. Okay, so we don't even need to look at the 3. In this case, all I did was I changed it to improper, and then I times out, which made life a little bit more hectic. But in this case, all I did here, and it's the same question, was I just took the 2 fractions. So I'm going to do it over here for you so you can see what I mean. So it looks like I've ignored the 3, which I kind of have, but obviously it's still the same number. So it's the fraction that's going to tell us which side to go. So if you look here, I've got 4 and 2 make 8, and I've got 7 and 1, which makes 7. Which way is my crocodile going to go? Absolutely, it's going to go to the right. Okay, so that is a nice, easy little method. I mean, if you aren't great at converting to improper, then I wouldn't suggest doing this one and rather keeping it simple like this. Most will choose this one. So now if you look at all my questions here, you'll see that they're all at the top here, they've all got a whole number in it. So technically you don't have to even look at the whole number. All you have to do is look at your fractions, and then you're good to go. Now just be careful, because sometimes we might put a 5 here and a 6 there. You don't even have to work it out. You know that 6 is bigger than 5, and automatically you'd be able to put that in. Okay, so if we look at this one, we've got 5 and 7, and you can kind of just go over it. It doesn't matter. 5 and 7 is 35, and 10 and 3, that's a bit of a dodgy looking butterfly today, but anyway, and you've got 30. Can you see that? You can see that that side's bigger, and you're going to do the same for all of them. Okay, all right. Obviously they do get a little bit harder. Sometimes they give you some nice little, well, not little fractions, some nice big fractions here. If you can't do them, do your working out on the side. Okay, no one is stopping you from doing that. Okay, I want you to try these on your own and see if you can do them. Now here are the answers. You'll see I just did a quick one and it's like speeds through it, but you can see that this side, the right hand side, will be obviously bigger than, so this side is smaller than that one. Here you've got the same 22 and 24, so clearly that side's going to be bigger. Here you've got 10 and 4 over 8 and 10 and 9 over 12. That side is going to be bigger this time, and so forth, and I've done them all for you. Thank you so much for watching this today. I really hope it's helped. Please subscribe to my channel, and soon I will have some more videos on addition of fractions, subtraction of fractions, multiplication of fractions, and all the other things that you can think of. We will go into decimals and percentages. Cheers for now.